plan for today, guys? We're going to do exercise 7B question 4 together. Okay, there's a few proofs going on here. And then we will look at 7C. You should fly through 7C because we've seen it before. And then we'll do some of 7D together, which is another sort of proof exercise that we're doing. Now, I've got worked solutions for this question and for exercise 7D. I've attached them to sector, so tonight when you're a bit stuck on 7D, you can have a look at that. So what we're going to do is we're going to prove that the sum of two even numbers is even. So like you can just think about it, if you have 2 plus 4, they're both even numbers, and when you add them together you get 6, which is also an even number. So we've got one piece of evidence to believe it. But we're going to prove that it's true for all even numbers. What we're going to do... Okay, so what we're going to do is we're going to define the numbers. We're going to say the first number is 2n, and the second, so let's let 2n and 2m be the numbers where n and m are both integers. Okay? Now this is something that we know to be true, is that any number multiplied by 2 is always an even number. Okay? All of the multiples of 2 are even numbers. Right? So therefore for any integer n, for any number n, when we multiply it by 2, it's also going to be even. So we know this is an even number because it's multiplied by 2, and we know this is an even number because it's multiplied by 2 as well, regardless of what number they are, as long as it's an integer. Okay? Then what we're going to say is the sum of two even numbers. Well, what's that going to be? So the sum of two even numbers is going to be 2n plus 2m. Right? And this is equal to 2 times n plus m. Okay, but what was our first rule? Alright, our first rule that we've set up here is any number that's multiplied by 2 is going to be even. Down here, it doesn't matter what n and m are, it's always going to be even. Okay, so let's justify that. Therefore, all even numbers. Therefore, the sum of two even numbers is even. Two even numbers is even. Two even numbers is even because it's a factor of 2. Alright, so because 2 is a factor, doesn't matter what these values take, the solution is going to be an even number. Now we're going to apply a pretty similar rule to question B, which says the sum of two odd numbers is even. Okay, so we've got two even numbers, you add them together, you get an even number, and now we're saying two odd numbers. 1 plus 3 is 4. 3 plus 7 is 10. Okay, so we can see the sum of two odd numbers is even as well. Now we're going to prove it. Now the way we define an odd number is 2n plus 1. Alright, so we know that this is even, and then plus 1 makes it odd. So we're going to have 2n and 2m plus 1. And when we add them together, okay, the sum of them will be 2n plus 1 plus 2m plus 1. This is 2, sorry, I should write up here just for good communication. N and m are both integers. 2n plus 2m plus 2, which is equal to 2 times n plus m plus 1. Alright, so it doesn't matter the value of n and m. We've said if it's a multiple of 2, it's going to be even. We've proved that two odd integers will always be a multiple of 2. Alright, so then we can write. Therefore, the sum of 2 is even because it's a factor of 2. Brad, you okay?
Yeah.
Alright. So then we're up to C. The difference between two rational numbers is a rational number. Alright, so I'm going to rub out A here. So what is a rational number? We're going to let the rational numbers be, could be anything, A on B and C on D. They're rational numbers because we can express them as a fraction where A, B, C, D are integers. Okay? And we're saying the difference between them. That means when you do one of them, subtract the other. Okay, one rational number, take the other rational number, the answer is going to be rational. Well, if we're going to perform that, we're going to have A on B, take C on D. Before we can perform this operation, we need them both to have the same denominator. So what do? We cross multiply those denominators. I'm going to multiply this one by A on A, and this one by, D on D, and this one by B on B. Okay? And then what you can see is we've got AD on AB, take away CB on DB. What have I done there?
AB.
That's a D.
DB.
Yeah. Okay. These have the same denominator, which means we can perform the operation. It's just going to be the top take away the top. So that's AD take CB on DB, which is a rational number. Okay. A, B, C, D are integers. Therefore, for any two rational numbers, the difference between them will also be rational. Why is it rational? It's rational because it's expressed as a fraction. Alright, and then part D, the product of two rational numbers is rational. This one's absurdly easy. Okay, we have A on B times C on D. That's AC on BD, which is a rational number. Yeah, that's a boring one. Okay, let's look at what we're going to be doing in 7C. So let's open up our notes books to 7C. We've got division by Surds. And the example we're confronted with here, take this, says the notes book. We've got 3 on 2 plus root 5. And it says write in the form A plus B root C. Alright, so it wants us to write it as with the surd at the top. Okay, it wants us to get rid of this denominator. Alright, it wants us to write it without a denominator. So, can anyone remember how we do this? How we get rid of a surd denominator?
Times it by 2 minus root 1.
Excellent. We multiply it by, what's that called? The conjugate. We multiply it by the conjugate. Okay, so the conjugate of 2 plus root 5 is 2 take root 5 on 2 take root 5. And this is a legitimate operation because we're not changing the value of it in any way. That's just 1. Okay, it's just a number 1, and so we've still got one lot of it. And the beauty of this is at the bottom we have a difference of 2 squares. We've got A plus B times A take B. We know that rule off by heart now, I hope. A squared take B squared. Okay, so at the top, we've got 3 times 2 take root 5. That's going to distribute. We're going to have 6 take 3 root 5. And at the bottom, we're going to have A squared take B squared. So it's going to be 2 squared take root 5 squared, which is, I'll write it out, and we can simplify it. So at the top, we've got 6 take 3 root 5. And at the bottom, we've got 4 take 5. So we've got 6 take 3 root 5 on minus 1, which is minus 6 plus 3 root 5. Alright, so that's what we're doing a bit of in this exercise, 7C. So let's spend probably 20 minutes, I reckon, 20 minutes to half an hour doing it, and then we can have a look at some of 7D. Let's do it.